Hello everyone. Today we are going to work on measures of central tendency. We're starting our new unit. It is on statistics. So this is all about really how we can apply math to our everyday lives. And today is about looking at numbers and looking at how we can define what they tend to do, especially in the center of those numbers. So central tendency are central values or the center of a data set. There are three types of central tendency numbers. There's the mean, the median, and the mode. To find the mean, you find the average for a set of data. And if you didn't know how to do that, you add up numbers and divide by how many numbers you added. So say I had 6, 7, 8. I would add up 6, 7, and 8. 6 plus 7 is 13, plus 8 is 21. And since I added up three numbers, I would then divide by 3. 21 divided by 3 is 7. And there you get your average. So again, I did 6 plus 7 plus 8. And there's three numbers there, so I divide by 3. Normally, if you put this in your calculator, you would put parentheses around the top. To find the median, it is going to be the middle value for a data set, and specifically it has to be listed in order. So that's going to be our biggest thing, is always listing our numbers in order. Finally, the mode, and that is the most frequent occurring values in a set of data. So the number of times it is used. That's what frequency means. Two other really important sets of measurements we can take for a set of data is the range, which is the difference between the highest and lowest values in a set of data. The highest is known as the maximum, or you'll see max, and the lowest is known as the minimum, or min. And so to find the range, we do the max, subtract the min. And then finally, the outlier. It is the value that is drastically different from the rest of the data in the data set. Either it's really high compared to the rest of the data, or really low when compared to the rest of the data. So when do we use each of these? When are we going to use mean, median, and mode? So we're going to use the mean when the data is evenly distributed. Data evenly distributed. It's going to be symmetrical. So about the same amount of data on the left as the right. This is going to look like a bell curve, and we're going to go into that a lot more tomorrow. You use the median when the data is skewed one way or the other, left or right. And we'll talk about what being skewed means in just a second. And then you use mode when you are dealing with nominal data. Nominal meaning just the name of the data. So this is like with zip codes, or when you're talking about jersey numbers. Mode is not normally used. Sometimes it's used when you're skewed left or right, but generally mode is not the measure of central tendency we're going to use. So we have a frequency table over here. And the frequency table shows the number of job offers received by a student within 2 months of graduating college with a mathematics degree from a small college. So we need to find the mean, median, mode, range, and the best measure of central tendency for this data set. So let's start by writing out these numbers. So the student received 0 job offers twice. So it's 0, 0. And then 1 job offer twice. 1, 1. And then 2 job offers 4 times. So 1, 2, 3, 4. So I'm just recreating this frequency table so that we can see all the numbers. And then 3 job offers for 5. 1, 2, 3. Oh, sorry. 5 job offers for 3, 4, 5. So there's 5 students who received 3 job offers, so we need to have 3 5 times. And 2 students received 4 job offers, so we have 4, 4. Now remember, to find the mean, it is the average. So what you're going to do is you're going to take your calculator, you can use Desmos, whatever you want to do, and you're going to add up all these numbers. So it's 0 plus 0 plus 1 plus 1. My kitty wants to come say hi, but I got to tell him, no, not right now. Okay, plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 3 plus 4 plus 4. So all I did was type in all the numbers that we have, and I'm going to press enter. And that's going to give me a total of 33. So it's going to be 33, and then we're going to divide by how many numbers we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. So we're dividing by 15. So now that we have that, we're going to put that in our calculator. We're taking 33 and divided by 15. And we get the mean is 2.2. And this is sometimes abbreviated, it's actually X bar, meaning the mean or the average. So the average is 2.2, specifically 2.2 job offers. Now the median is the middle number. So we're going to start on the outside and start counting in. It's 1, 2, 3, 4, 5, 6, 7. It's this number right here, or 2. Another way that you can do that is that you can see there's 15. 15 divided by 2 is 7.5. So I need the 8th number because 7.5 rounds up to 8. If you have an even number like 16 and you divide it by 2, 16 divided by 2 is 8. I need the number between 8 and 9. And sometimes you have to find the average between those two. So here my median or my middle number is 2 because it's the 8th number, or as we counted in, we found 2. The mode, the most frequent number. Well, you can look at this and see that it's 3, or you can look up here and see the frequency of 3 is 5, which is the most. So my mode is 3. And lastly, our range. Our range is going to be the highest number subtracted by the lowest number. My dogs wanted to say hi. And 4 minus 0 is going to be 4. So the maximum minus the minimum equals 4. Now, what is the best measure of central tendency here? Well, the data is pretty evenly spread, so we could do the mean. Some people might say that this data is skewed left because you do have kind of a lot of data on the right. But since the mean and the mode are pretty close together, either one can be used. So either mean or median are close together, not the mode. We don't use the mode. The mean or the median would be used. Generally, since it's symmetrical, we would say the mean. So I'm going to put a circle around the mean. But it's when the mean and the median are drastically different, that's when we have to look at, is this data evenly distributed or is it not? Alright, let's look at example 3. Example 3 asks us to identify the outlier in each set of data. So before we identify an outlier, we always need to write the data from least to greatest. Some of you might be able to identify the outlier before even doing that, but I always suggest doing that because normally we have to do a lot more with the data than just find the outlier. So the first number, the lowest number is 2.1. So I'm going to write that, and then I'm going to put a line under it so I know that I've already written it. And then we have 2.3. And then we have 3.0. And then we have 3.0. Ooh, I missed one. I missed 2.9, so I'm going to rewrite. It's 2.9, then 3.0. This is generally why I always ask you to use pencils, but I forgot to grab them from the school before I left. And then we would have 3.3, and then 3.4, and then 4.5, and then 5.9, and then 9.8. So looking at this data, is there a data point that's drastically different, like either below or above the data compared to everything else? So the outliers are either going to be the minimum number or the maximum number. And here, 9.8 is pretty different from the rest of the numbers. If you look, there's a 2.1, 2.3, they're kind of the same. And even though the 5.9 is a little bit high, it's not that high. Whereas 9.8 is pretty high compared to the rest of the numbers. I want you to try to do B by yourself, so pause the video, try and do B before I do it with you. Alright, we're going to write these from least to greatest. So we're going to start with 0, and then 10, and then we have 11, and then 15, and then 16, 17, 2 19, so we're going to write them twice, and 21. And if you notice, I forgot one. It happens. It's okay. We're going to put 14 in right here. Sometimes I'll do that, especially if I have already written it. I'll just put a little arrow up. It depends, but I had a little bit of room, so I added in 14. So now, what data set number do you think is drastically different from the rest? I personally think it's 0. Again, it's either going to be the first number or the last number. 21 is pretty close to 19, so I don't think it's the last number. 0 is pretty far away from 10, just so you guys know. Looking at B, what would be the mode? So think about that right now. What would be the mode? Well, the mode would be 19 because it's here twice. There's no other number that's used twice. Looking at A, what would be the mode? Well, there's no number that's used more than once, so we just say there is no mode. There's no mode for A. Alright, let's look at example 4. Now, I've seen questions like example 4 on an EOC, so we want to make sure we really understand this type of question. You scored an 83%, 74%, 95%, and 76% on your last 4 math tests. Also, I have a lot of you guys asking me this question too. If you want to earn an 85% in the class, what score must you get on your next math test? So I have an 83. And if I want to score an 85%, that means I'm finding the average. Because I need to find the average of all of these. So I have an 83 plus a 74 plus a 95 plus a 76 plus an unknown, because I need to know what I'm going to get on my next one. And that's going to be divided by how many total ones I have. So there's 1, 2, 3, 4, 5. I'm dividing by 5. And I need that to equal my average of 85. So let's simplify this a little bit. Let's add up 83 plus 74 plus 95 plus 76. And I get 328. Just so you guys know, I got 328. So I have 328 plus x divided by 5 is equal to 85. Now, try and solve this yourself first, but if you need a little bit of help, there's 2 ways you could do this. You could either put this over 1 and cross multiply, but another way of knowing how to do it is this is being divided by 5, so the opposite of division is multiplication. We're going to multiply both sides by 5. That cancels out these 5s, and I get 328 plus x equals whatever 85 times 5 is, 425. Now to solve this, I would subtract 328 on both sides. So you have 328 plus x equals 425. Subtract 328 on both sides. And we take 425, subtract 328. and we get 97. So X would equal 97%. What does this mean? This means that I would need to get a 97% on my next math test in order to have an 85% in the class, if these were my first 4 grades. Alright, I want you to try and do number 5 by yourself before you watch me do it. So try and do this one first by yourself. Okay. You scored a 99%, a 67%, an 83%, and an 86% on your last 4 science tests. If your next test counts twice, is it possible to average a 90%? Explain. Well, let's look. I have a 99 plus a 67 plus an 83 plus an 86 plus what I'm going to get on my next one, but it counts twice. So 2x, because it counts twice. And that's all going to be divided by 1, 2, 3, 4, 5, 6, because it counts twice, to give me 90. Well, let's try and figure this out. We're going to do the same thing we did last time. We're going to add them all up. 99 plus 67 plus 83 plus 86 would give me 335. So 335 plus 2x divided by 6 is equal to 90. Like we did last time, we're going to multiply both sides by 6 to get rid of the 6 in the denominator. And we get 335 plus 2x is equal to 540. And I'm going to be real, I did that one in my head because 6 times 9 is 54, and then you add the 0. Next, I'm going to subtract 335 from both sides. And 540 minus 335 is 205. So we get 2x equals 205. Hopefully next you know we divide by 2, and we get that x is equal to 102.5%. So is it possible to get a 90% average overall? Yes and no. It depends on if your teacher allows extra credit. If your teacher allows extra credit, it's perfectly possible. But if your teacher does not allow extra credit, and I don't know what your science teacher does, then it's not possible because you can't get over 100% if there's no extra credit. Okay. We're going to keep going on just for some practice because it's always good to get some practice. Okay. The heights in inches of 8 tomato plants are 36, 45, 52, 40, 38, 41, 50, and 48. Find the range, mean, median, and mode of the tomato plant heights. Now, first of all, I want you to try doing this yourself before we do it. So try it yourself, and then we'll do it. Okay. Before you even start, you should always write these in order. And as you can see, I'm not the greatest at writing in order, but we're going to try. So 36, 38, 40, 41, 45, 48, 50, and 52. And if you forget a number, don't stress about it. Just go back in and write it in. It's not the end of the world. First, we're going to find the range. And if you remember, the range is the highest number minus the lowest number. So in this case, it's going to be 52 minus 36. Or my maximum minus my minimum. 52 minus 36 should be 16, and it is 16. So my range is 16. Next, we're going to find the mean. The mean is also known as the average. So we're going to add up all these numbers and divide by how many numbers we add up. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers. So let's add them all up first. We have 36 plus 38 plus 40, plus 41, plus 45, plus 48, plus 50, plus 52. Again, you can use Desmos or your phone calculator to do this, whatever works for you. So I have 350, I'm going to divide by 8, and I get 43.75. So my number is 43.75. That is my average or my mean. Next, we need to find the median. And to find the median, we are going to take our inside, or we're going to count from the outside to the inside. So 1, 2, 3, 4. And as you can see, there's no number in between here. So we have to find the average of these two numbers, or the number that would go right in the middle. So what's right in the middle between 41 and 45? It's 43. But also we can find the average between those two numbers, between 41 and 45. 41 plus 45, and I added two numbers, so I'm dividing by 2, and I get that the average is 43. Either way works. If you can find the number between, please do. If you struggle with that, that is fine. And lastly, the mode. The mode is the most frequent number, and there's no number that's repeated, so there is no mode. If there are multiple numbers that are repeated, like say 48 was up here twice and 50 was up here twice, we would list both of them. But there's no numbers that are repeated whatsoever. Alright, we're going to do one more together. You and your friend have a friendly competition going on about the scores on your math quizzes. Both of your scores for the first 5 quizzes are shown below. So you have your scores and your friend's scores. Find the mean, median, and mode of both sets of data. Do you or your friend have the higher mean? Who has the highest median? So first we're going to do your scores. And we're going to do your mean, median, and mode. Alright, first of all, remember, we always have to write these from least to greatest. Always, always, always. So I'm going to do these over here. It's 15, 16, 17, 18, and then 19. So that's for yours. And the kitty wants to say hi again. Maybe he'll be in a later video. Alright, so first of all, our mean. We're going to add up all these numbers and divide by 5 because we're adding up 5 numbers. So 15 plus 16 plus 17 plus 18 plus 19. We get 85, and then we divide by 5 because that's how many numbers we added up, and it's 17. So my mean is 17. Now we need to find our median. So we count 1, 2, and 17 is right in the middle, and our median is our middle number. So median, middle number. And then the mode. What is the most frequent number? Well, there isn't none for us. There isn't any for us because there's no number that's repeated. So next we're going to do our friend. And as you notice, I'm organizing my work on here. We really want to make sure we're organizing work and can find our answers when we're writing them. So my friend scores. They have a 12, a 13, a 17, a 20, and a 20. So let's find our mean, our median, and our mode. So to find our mean, we are going to add 12 plus 13 plus 17 plus 20 plus 20. And we have 5 numbers, so we're dividing by 5. And we get 16.4. So our mean is 16.4. Next, our median. We're going to start on the outsides and we're going to count in. 17 is our middle number. So that is our median. And our mode, our most frequent number, is going to be 20. Now, do you or your friend have the higher mean? Well, I have the higher mean. So you have the higher mean because 17 is greater than 16.4. Who has the highest median? Well, both of our medians are 17. So our medians are the same. Or your medians, you can say your or our. Okay, so we're going to stop here for now with the video. I know there's some more work on here. You're welcome to use it to practice, but don't feel obligated to. There should be another video coming up that shows you how to put some of this data into Desmos so you can use your online calculator to find some of these numbers. Have a wonderful day.